So right now, I would like to welcome our three guests: James Frasher, Senior Strategic Business Planner and of Energy Storage and DER Operations at SMUD; Timothy Barat, Co-founder and CEO of Gridware; and Peter Kelly-Detwiler, Co-founder of Northbridge Energy Partners. First, I would like to welcome James to come and share his slides and tell us a little bit about what he's working on with SMUD.
Awesome. Thanks for the intro there, Thomas. That was really nice and some awesome information and setup. So let me just pull up my slides here real quick. And just as a courtesy to everyone on the call, I do have twin 5-year-olds in the house. So if you hear them in the background, I apologize for that. Don't be alarmed. They are that loud all the time. So let me go ahead and click the share button, make sure that everyone can see my screen. Thomas, if you give me a thumbs up or just let me know that you can see it, then we'll be off to the races. Awesome. Very cool. So I certainly appreciate the commentary on the grid and kind of the evolution and the change and the direction that everything is going. Because there is a significant amount of change kind of in the pipeline, and it's something that we're all really aware of, and we're striving hard to kind of help facilitate the right transition to happen. And when I say we all, I don't necessarily mean SMUD. I mean really us as a community. It's a much bigger problem that we're trying to address than just the electrical system. It's really a holistic solution and opportunity. My name is James Frasher. I work for SMUD as a senior business planner. I've been with SMUD now for about 5 years. Before joining SMUD, I came from the private sector, where I was a battery system engineer for about 12 to 14 years, designing battery packs for anything from electric trains to very early plug-in hybrid electric vehicles. I've done battery systems for cranes and class 4 through 8 semi-trucks as well. So pretty extensive experience from the battery energy storage side, at least in the operational side. And so I came to SMUD really with the intent of trying to figure out how to apply my skill set to bring that value and the potential of those technologies that I'd worked on in the past into the utility space, to try and figure out how I could help bridge the gap between the conversations that I was having in the private sector side, talking with venture capitalists, working to start businesses and launch companies, and really meld that with the conversations that were happening at the energy trading desk and during resource planning and during grid operations. My experience in the past was that there was a lot of miscommunication, different use of terms, and I really saw these two worlds on a path to convergence and coming together and partnership. And so it's really cool to kind of be here today to get to talk to everybody about distributed energy resources and virtual power plants, because I think that really represents kind of that path of convergence that I was looking for when I joined SMUD. And so with that, I've got a presentation here that's going to take probably 5 or 6 minutes. And really, I just want to kind of walk through and share a little bit with everyone the path that SMUD is on, how we got onto that path, and how we're prioritizing the conversations that we're having. And then dive a little bit deeper and talk about how we're actually striving to position virtual power plants and these distributed energy resources to be a major component of the long-term operation of the grid, for it to be a core competency, not an externality that we're using as a pilot or something that's new and interesting, but really something that is old hat and relied on and can be trusted well into the future. Just as a little bit of background, for most people, this being a largely regional group, this is all pretty obvious, but I do like to include just a high level summary of kind of who SMUD is, just to set the framework for everybody to have the conversation. We serve roughly 1.5 million people here in SMUD. That accounts for just over 600,000 customer accounts. And SMUD itself, we're just above 2,000 employees. And so that's kind of the group that we represent. We are a vertically integrated utility, so we operate the Balancing Authority of Northern California. We also own our own, several of our own power plants. We own our own distribution system and grid operations all the way down to the point of delivery. So we are fully integrated, and in that context, we're also not for profit. We're governed by a community elected set of 7 board members, which represent 7 wards across the service territory here in Sacramento. And that board of directors sets the direction and vision for where SMUD is trying to go. And so largely that is the source of the push that we are on today to really accelerate this decarbonization conversation. In 2018, that started with our board adopting a very ambitious integrated resource plan that put us on a path to achieve net zero carbon by 2040. And net zero was going to achieve zero carbon emissions through a combination of electrifying buildings, electrifying transportation, decreasing the reliance on our thermal power plants, and increasing the utilization of distributed energy resources. We set out on that path. We started making strong progress immediately. And actually in 2020, our board continued to raise the stakes for the organization and provided what is really the most ambitious environmental objectives for a large utility that we're aware of in the world, and at least in the country. To that end, we are striving to achieve 100% carbon-free energy on the electrical grid for our customers by 2030. So looking at what implications that has for the 5 natural gas power plants that we have, and really figuring out how we can redesign that aging and potentially at points lagging grid infrastructure, reimagine that, and structure it in a way that lets us move away from those carbon emitting resources, lets us move away from those negative environmental impacts that these types of systems have, and really embrace the zero carbon renewable energy, battery energy storage future that up until recently was never possible before. And when we look at the technology and the pace of development and the innovation that's going on both within utilities, but also within startups and these evolving businesses, there's a lot of new thinking going on that really is necessary to enable this type of future. And so the vision that our board put in front of us is, how do we use what is near term, what is known, what is tried and true to start the transition? And how do we reach out and engage with the broader innovative industry and deliver on that last 10% or that last portion of those carbon emissions to go beyond that net zero that we had envisioned in 2018, but really to get to 100% carbon free. We did that by kind of setting our zero carbon plan up into these 4 different verticals. And I'm just going to walk through these quickly left to right, and we can dive deeper in any panel conversations if that's where the conversation goes. But we started by looking at our thermal plants and asking ourselves, how can we reimagine the operation of those plants? And so we're looking at retiring 2 of those power plants in the coming years, and then analyzing the transition or retooling of the additional power plants, either retirement or transitioning fuel sources, also investing in carbon capture, to move those power plants to a cleaner, more sustainable future. Additionally, engaging in proven clean tech. Obviously, solar is a very proven and established technology. Wind is also a very high level renewable. But large-scale energy storage is broadly adopted at this point, and a number of behind-the-meter battery energy storage systems as well really fall into this category of proven clean tech. The area where I really focus my time and effort as a strategist at SMUD is looking at this 3rd vertical, or this 3rd swim lane, the new technology and business models. And that's really where we're starting to ask the question of, instead of a customer installing a behind the meter battery and operating based on our time of day rates, how can we instead partner with that customer? How can we engage with their battery system and escalate the operation of that device into a virtual power plant mode of operation, instead of just responding to seasonal based time of day rates that may or may not reflect the real time needs of the grid at any given moment. And so really pressing the envelope on what technology can do and how we can partner with our customers to make that possible. And then the last swim lane here, and this may be the most important, is really making sure that we're doing this, that we're taking on these efforts, that we're considering this new technology in a way that is financially responsible, making sure that we're not passing the costs of this directly on to our customers, especially those that may be under-resourced, and that we are looking at holistic solutions that provide lowest cost, best value opportunities, so that we can achieve this zero carbon future, but also do so in a way that is financially sustainable for both SMUD and our customers. And so really making this a future that is lasting, not just a future that is, we got to 2030 and then things fell apart because we didn't plan for beyond that. And so doing things in a way that is lasting and durable is really important to the way that we're addressing this. With that, our virtual power plants are really looking at how we partner with those customer-sided devices, be that thermostats, electric vehicles, behind-the-meter batteries, solar, pool pumps. All of these are dynamic energy-using devices. All of these are paired with aggregators that can communicate using open standards, that can turn one device into an aggregation of thousands of devices that can then provide meaningful grid response. And so these virtual power plant efforts are really looking to bring that solution set online. Bringing your own device, making sure that we are open to a broad set of technologies. We're not just keying in on this particular thermostat and this particular battery, but rather making best use of all of the available technologies. And then doing this in a way where we're starting with pilots, we're building confidence, but we're designing pilots with the intent to scale into long-term lasting products. To give everyone an idea of the timeline that we're talking about, these pilots are efforts that we are actually launching right now. We've got a number of solicitations that have gone out this year and a few more that'll be going out later this year. But really looking to bring these virtual power plant efforts online. Next year, we'll be doing integration with those aggregators and bringing the early enrollment to these systems to the table. The idea is that we're going to be establishing operational confidence by 2024 so that we can actually facilitate the retirement of those thermal power plants that we mentioned earlier, and so that DERs can be at the table when we're talking about how do we reimagine those additional thermal power plants that will need to transition as we move closer to 2030. So all of this effort is really focused on bringing DERs to the point where they are a trusted and validated resource with a known cost that can then be compared to the competing solutions. And the grid and the electrical operators and resource planning is then in a position where we can make the most cost-effective decision to advance the overall zero carbon initiative that we have planned. There's a lot of changes and a lot of new partnerships that go into that. Customers are no longer just buyers of energy. They're now customer partners. It's now a transactive relationship in this virtual power plant world where SMUD is providing energy to customers, but customers are also part of that energy service conversation. It's a bi-directional partnership now. It's no longer a simple buyer and seller type relationship. Third-party aggregators are critical to the success of this type of solution, and it has to be done in a way that integrates with the grid and the way that it operates today. We're not going to rebuild the entire electrical system overnight, and so we have to transition these solutions in based on how the system operates today, and then grow from that point. Looking at how we participate in the different energy markets, be that CAISO or the energy imbalance market, or how it affects SMUD's operation of the Balancing Authority of Northern California, all of those things have to remain reliable. That resiliency component is critical. And then really at the end of the day, we want these resources to be part of the long-term plan. And so it can't be just kind of, here's how many batteries we happen to have. It has to be here's the forecast for 2023, 25, 28, and here's how we're going to rely on them. And we're actually not buying other capacity. We're making the decision to not put concrete and steel in the ground because we can trust these virtual power plants to deliver the same service. And that is a paradigm shift away from the conventional and into the future. And I think a lot of actually what Thomas was referring to in this rebuilding the idea of what grid infrastructure is and investing in it in a way that enables renewables and technology to be a star player in that long-term solution. For us, it means that we're getting rid of those conventional concepts or at a minimum adding to them in terms of virtual power plant. No longer do we talk about construction time in terms of virtual power plants. We now talk about how long it takes to recruit customers into the solution. It's not a specific purpose built like a substation to serve a new community. It's now value stacking. It's a battery energy storage aggregation that is providing congestion relief during evening peaks, but also providing grid services when there's a larger system need. It's not a single partner that happens to own and operate a power plant, but rather aggregations of potentially tens of thousands of customers. This isn't SMUD owned technology anymore. This is now customer owned. And the operation life of a traditional utility investment is not the same as these DERs. And so making sure that we're considerate of that. And doing so in a way that provides that long-term trust that those resources are going to be there. And so this is all kind of how we think about bringing these resources to the table. And just the last slide that I have here before I hand it back to Thomas is just this idea that we're not designing something that is going to be long-term more expensive than the alternatives. We're trying to design a solution that is cost competitive, that is cost effective against the alternatives that are out there. And so at the end of the day, as a utility, we have the ability to go out and buy very large batteries. We have the ability to invest in wind or invest in solar or bring different types of resources onto the system. We want virtual power plants and distributed energy resources to be side by side in that conversation. And we want to do a good enough job in developing these virtual power plant solutions and partnering with customers and aggregators that they're cost effective with those alternatives, and that virtual power plants are potentially one of the reasons why we're able to attain zero carbon by 2030 in a cost effective way that delivers benefits to not just participating customers, but really our entire community at large, and delivers that value in a way that is a partnership between SMUD and our customers. And so I've got my contact information on this slide. And so anyone that would like to reach out to me with additional questions, please feel free to. And beyond that, I am very much looking forward to the conversation that we're about to have.
Oh, thank you very much, James. I'm gonna.
There we go.
Thanks, Thomas. Appreciate the opportunity to be here today. It's a kind of a good segue from the last presentation, but today I'm going to be talking about how we can create this affordable and cost-effective clean energy future by focusing on something that may not always be spoken about. And there's two elements to the rates that go out to ratepayers. One of them is reducing the cost of actually producing the energy. And I think a lot of the conversation centers around there, but also the utility operates its rates under the O&M costs. And so today I'm going to speak a little bit about that side of things. A little background about myself. I'm currently the co-founder and CEO of Gridware. We are originally a Sacramento startup. I lived in Folsom for 8 years. Prior to that, or during that time, I studied electrical engineering and computer science, both my undergraduate and graduate degrees at UC Berkeley. And prior to that, I was actually a line worker in Australia before moving out into the US. So I hope that I can add some value to this conversation. And so I want to bring some of the things that I've been thinking about over the past couple of weeks. And when Thomas reached out and mentioned that we'd be centering this discussion around DERs, it's been something that has been on my mind. And so as we start to see the proliferation of grid edge, the result is going to be less utilization in T&D. See, because as we increase load independence, you have microgrids, nanogrids, solar, wind, all of these resources being deployed closer to the load. It means that the independence would decrease the utilization because you have homes that offset their energy usage because they're generating their own electricity. And that really impacts the distribution grid. And then collectively, if neighborhoods are balancing their energy usage, then that will impact the transmission. And so the problem with this is, or one of the challenges regarding this is the cost of the T&D assets and operating and maintaining them is independent of utilization. Regardless of how much DERMs or DERs get incorporated into the grid still needs to be able to support large spikes when things go wrong. And, we kind of saw that in Texas, and we've seen that many times now as we've seen these increased frequency of extreme weather events. And then furthermore, for this to actually work, the homes and businesses and neighborhoods and the states still need to remain connected for redundancy and to do the trading that we're facilitating. And, there's two modes of operation now. I think most people talk about how we transition to the clean energy future, where you kind of have this central organization, kind of like a Cal ISO, or even in higher than that, that takes control of all the grid edge. And then you have this kind of layered approach. But regardless of which way we choose to operate in the future, or we transition to, we still need the T&D. And so what ends up happening is we need to upgrade the T&D to support this new proliferation of decentralized and renewable energy sources. And the T&D needs to be upgraded to support all the different things that are happening, like the electrification of vehicles. And so the cost of operating the T&D is actually increasing. And so this is challenging when we start to talk about affordability, because you've got decreased utilization and it doesn't result in a decrease of cost. In fact, what we see is an increase in the amount of cost. And so for us to drive towards an affordable clean energy future, we need to offset that. And then the main central argument that is generally spoken about is, well, the DERs are going to be able to reduce the costs of actually producing energy. We are getting to a point where there are technologies that can generate and share electricity such that it's net positive from fossil fuels. But I really wanted to spend some time today talking about how we can reduce and offset this cost by getting into the operations and maintenance and really driving some efficiency there. And that centers around grid intelligence, really having that knowledge and situational awareness of all the equipment out in the field, and kind of list some of the ways that I think that grid intelligence could help offset these costs. So the first one is real-time asset management. And here what I'm talking about is if the utilities and the operators really were connected to their infrastructure and they understood what was going out there, and then this could be in the form of sensors, data analytics. There's many different ways and approaches to kind of building this out, but it really enables the utility to run the equipment to the point of diminishing return. Right now, we have to run the equipment to point of failure, and that's not optimal. You either are uninstalling or replacing your equipment too early or too late, and then things go wrong. And we spend a lot of time and money doing these manual and visual inspections and they can only happen maybe once every 10 years. And this means that most likely we run to point of failure. And so if we had that connection or that visibility into the equipment, you'd be able to perform selective hardening. You would know exactly where to target your upgrades, and you would be deploying your capital effectively. You could do preventative maintenance, and this would drive down the cost because you are only deploying capital where it's needed. The second way, I think that real-time situational awareness can help drive down these costs is with pre-outage analytics. So if we can anticipate what's going to happen, we have weather models, we understand what's coming up, whether it's days in advance, weeks in advance. This allows us to plan for that. And this can involve setting up the right crews with the right equipment and just getting ready for when things go wrong. And then when it does go wrong and you have these extreme weather events, how do you assess the situation? You have a transformer that might be out and a pole down, as an example. And you have two crews. One crew has a replacement transformer on the back of the truck, and another crew is set up to replace the pole, and they have the winch. You've got to send, and there's a situation where you send those two crews to the wrong fault because you don't know what happened. And then they have to cross wires and go back. And this is a wasted truck roll. And so if you're able to optimize that and manage that, this comes from having situational awareness, not just when things are okay, not just when outages happen, but also just in general day-to-day operations. And this also results in being able to predict when you can restore for your customers. And that results in customer satisfaction, which ultimately comes down to what they're willing to pay for their electricity. And then once once these extreme weather events or outages are over, we need to do a retrospective and understand what did we plan for and then what happened. And then you can understand where the deficiencies were and make upgrades to your planning and improve the performance of responding to these outages. Now, something that is increasingly becoming a problem is casualty. We are now experiencing year-on-year casualty resulting from grid failures, and this is driving up insurance premiums. And if we were able to reduce that by reducing the casualty, this is a great way and a great opportunity to reduce the costs to the ratepayer. And what we can do is avoid these things from happening in the first place. And that means reinsurance will be willing to come back and create a competitive insurance market. But then also you have utilities that are having to defend themselves in court against situations that they may not have been at fault. Some of these investigations are imprecise, and there's a lot of politics around what happens. And if there was the data to back up the claims, but also be able to allow utilities to support themselves with not at fault claims. And then kind of stepping back to the cost of producing the energy and distributing the energy. If we were able to understand weather patterns, understand how cloud cover shifted, this directly plays into several different factors within producing and distributing electricity. One exciting thing is improved IVVC. It's highly dependent on weather. And as you know, microclimates exist, and customer load behavior is very dependent on the weather. And so is DERMS. And so if you had that kind of visibility where instead of having a weather station every 20, 30, 40 miles apart, but you had high spatial and temporal resolution weather data, this would directly play into not just the operations of the electricity generation and distribution, but also risk models. And then finally, real-time GIS, having the understanding of where your teams are, where your assets are, where your inventory is, increased performance of revenue protection systems. Are there people that are maybe bypassing the meters, things like that. This all requires situational awareness. And so just to conclude, I think that there's a great opportunity for utilities to start thinking about how they can drive down their O&M costs by increasing the situational awareness. Thank you very much.
All right. Thank you very much, Tim. I really appreciate that. Next, I would like to welcome Peter Kelly-Detwiler, co-founder of Northbridge Energy Partners. He has more than 25 years of experience in the energy industry. His career is focused on the development of retail competitive markets, as well as new trends, technologies, regulatory and market developments, and sustainable solutions that create value in the energy space. So I'm going to stop sharing and highlight you, Peter.
Thank you. It's a pleasure to be here, and we're moving into a slide-free zone. And I first have to say I'm impressed with the points of view of our two prior conversationalists. And I've been a fan of SMUD since the days when S. David Freeman came riding into that place in the early 90s with his cowboy hat after he left New York Power Authority. You've been a leader in the space for a long, long time. And once again, you pick up the cudgel and move forward. And certainly, Tim, the issues around situational awareness have never been more critical than they are today. I had a chance, so I actually now have been in power markets for 30 years, and I actually was in retail in 97. And in the next to me in my bag, I've got the 3.5-inch floppy disk that holds the billing information from the first invoice ever rendered, because I did it, and I actually got the taxes right on the third iteration. By then, the customer had just about enough to do with me and hated the whole industry. So I didn't get off to a good start, but I ended up being with Constellation after we got bought, multiple iterations. You know, in the energy industry, you're wearing a new golf shirt every 5 years because somebody else owns you and it's a different 401k. And by the end of my time with Constellation, I was running a group with 1,700 megawatts of dispatchable load. We were the second largest demand response provider in the world. And in 2012, I left, and I really wanted to figure out where everything was headed, which is an immodest goal, but I ended up writing 300 and some 30 or so articles for Forbes and GE, interviewed the subject matter experts running the turbines, talked to the CEOs of the battery companies when they were small, and they were all still willing to talk to me, whether it was Fluence or Stem or whoever. And over the last 10 years, I've developed a fairly comprehensive view of how all the pieces fit together, which then I tried to throw into that thing behind me, the energy switch. And a critical part of what's going on is this distributed energy resource environment. And in the book, I actually had a chance to talk to Dan Sugar, and he runs Nextracker, which has over 20 gigs of solar on tracking arrays. And he was telling me that when he started, he was standing in one of the passes in California in the 80s and looking out across at all the wind turbines, the little ones back then. There were 500 megawatts. And he said to me, you know, back then I thought to myself, as a professional, if I can install 500 megawatts over the course of my lifetime, I will consider that a success. And then he laughed and he said, we're now doing that every week. And so I asked him, all right, so you got all this going on. You hear companies like Nextera and others saying, do we need to install batteries? And if you saw the EIA information that just came out yesterday, 2/3 of all the batteries coming into the system over the next couple of years will be installed with solar arrays. And I said to him, are you gonna have to jump into the battery game? He said, no, we don't think so, because distributed energy resources are gonna pick up the slack for us. We think that between batteries behind the meter and water heaters and EV chargers, they will start to respond to the market signals of negative pricing during certain parts of the day and the whole California duck curve. And eventually, to use my phrase, we'll tummy tuck the duck. That's trademarked, by the way, and I have t-shirts. So actually, don't laugh. Look, I do. Okay, so we will tummy tuck the duck, and we will do that with distributed energy resources. But if you're talking, you know, FERC order 2222, when Chairman Chatterjee rolled out that conversation last year and said to the ISOs, thou shalt come back with operating models by this year, explaining how distributed energy resources are going to be aggregated to 100 kilowatts and participate in the market. He cited one study with 380 gigs. And my response to that is like hell. That's not happening. I ran a DR group and I know how hard it was to get 1,700 megs. And the real reason the like hell is in place is not because the resources aren't there. It's because we don't have the underlying fundamental informational architecture and the situational awareness to make that happen. Let me give you an example of what I'm talking about. CAISO calls for 100 megawatts in a certain zone because they need it. And SMUD, well, let's take one of the IOUs. So SoCal Ed, PG doesn't know it's coming. And the preponderance of the assets it's called upon are locationally specific and they're batteries for the most part. So not just not consuming something, which is DR shutting stuff off, but real bidirectional flows. There's no way we're going to have thousands of megawatts of bidirectional flows over the current utility distribution systems we have today without an infusion of intelligence and software systems that tell the utility, oh, CAISO is calling for this. Here's where it is. Here's when it's going to happen. We're going to have to create some kind of an internet type of a situation where every asset is registered the same way we have a social security number for every human being. So we know where they are from a GIS perspective. We know what they're doing. We know how long they're going to do it for. And we know when they start and when they stop, right? Otherwise, vendors aren't going to have the confidence that they can actually get what they're trying to sell to the marketplace. The distribution companies are going to have no clue what's happening on their grids down at the feeder level. And CAISO is not even going to know whether or not it can physically be distributed. So the whole concept we have today with the 5,000, let's say, synchrophaser, phasor measurement units out there, the PMUs, that whole intelligence might have to migrate down to the distribution to the feeder level, which is what Hawaii is looking at right now, among other places where Hawaii is saying we're going to get 50% of our energy from the customer side of the meter. And in fact, right now in Maui, 22% of the energy they get on the island comes from customer solar, of the 50.8% renewables in the grid right now. So if we think we're going to get to the 380 gigs that Chairman Chatterjee cited without a radical rethink of how we're going to architect our systems, how they talk to each other, and how we're going to universalize the access to that data, we're fooling ourselves. We're going to have some kind of larger system that everybody can access that's permission-based. And by the way, it needs to be cyber secure as hell. So Enphase, company I love dearly, I've done really well on the stock, bought it at 97 cents. It's now at $85. So I love the guys. They scared the bejesus out of the cyber community with one single blog where they said, a guy in our control room remotely upgraded 800 inverters. He said, no issues with dogs chasing our people, nothing. We just remotely did it. And everybody in the cybersecurity said, holy, I won't tell you what they said. But it was really clear that the 2015 incident that the Ukraine suffered, where Russia attacked 3 of their distribution companies and blacked out 250,000 people for 6 hours through a cyber event that was focused on the industrial control systems, you don't have to go and attack the fortress anymore. Pretty soon, when we do have these multiple distributed assets out in the field, we're going to have to bother attacking the central fortress because there will be no central fortress. The fortress will be everywhere. And now, if you're a bad guy, all you got to do is go after the thinly guarded periphery, where the last thing vendors do is focus on cyber. So go after the weakly hardened assets such as batteries, EV chargers, and cycle the heck out of those things. And you can decentralize the grid that way, in addition to creating attack paths back to the mothership, because all the vendors will be connected to the utility. So now's the time, as we're talking about all this potential and efficiency that we can bring to the grid, which we most surely can. Now is the time for us to have those hard conversations, which are starting to happen in the SunSpec Alliance in California Rule 21, and some conversations in the DOE about, before we start to lay down all this track across the country in terms of all these independent spoken hub type relationships with vendors, we really need to step back and say, whoa, what are we designing for? What do we want this to be 10 or 20 years from now in a no regrets type of approach, so that we can facilitate all that growth without getting halfway down the road and going, oh shit, we poured the wrong foundation. Let's rip this whole thing out and start again. Pardon my French. That's where we are at this point in time. And that's what we have to think about on a go forward basis. So no slides. That's my pulpit speech. Bring it on.
Very good. Thank you very much. And
All right. Well, first of all, to James, Timothy, and Peter, big round of applause. Those were great discussion points. I think everybody has appreciated that. That's watching what we have here, and it brings so many thoughts. And Peter, I might start with you. First of all, Tummy Tuck the Duck is going to get somewhere into our write-up on that, so we'll put the little TM by it.
Please do, yeah.
Yeah, and also mention for people your blog. So how do they find that?
Oh yeah, so every week on LinkedIn, I do a 5-minute video with the top 4 to 8 stories around the world. And I just post it on LinkedIn every week, and I have a YouTube channel as well. And it covers everything from offshore wind to cyber to EVs to whatever's the flavor of the day.
Well, it's a good one to watch. It's very convenient and it's very short. But your last point, we're pouring concrete foundations on the wrong solution. I worry about that because in my approaching 50 years in the energy business, and you've got quite a bit too, I've seen that too many times. Mm-hmm. And there's lots of monuments to futility around the country when somebody thought they had the right plan, and then it turned out not to be, and we wasted a lot. The report that DOE put out, I don't know, a couple months ago, you reported on it on the blog, and it talked about, in order to meet the goal for climate change, here's where all the solar farms and wind farms are now, and here's what we're going to need, and dots all over the map, and here's the transmission lines that we're going to have to build. And I forget what the number was, but it was like 80,000 miles of transmission lines required and all that. That worries me precisely because of what Tim was saying. How do you pay for all that? And it's just going to look massively expensive if that's the route we take. And so it really brings into focus, how far can you push this DER thing? As some of you know, I ran a wholesale fiber optic network company on the East Coast. It ran from Portland, Maine down to Northern Virginia. But I mean, you were bringing in resources from all over the place and sending signals out. So that there was just the whole conjunction of sources and off ramps on the thing. And I'll tell you, we had plenty of algorithms, we had plenty of intelligence to control that thing. So the problem is solvable in software, but I think you nailed it, Peter. It's getting people to participate that have never participated before. But let me ask each of you, how far can we push this DER thing to avoid making a big mistake and saying that we've got to have an $80 trillion rebuild of the T&D system in order to meet climate goals? And let me ask Peter to respond to that first.
Yeah, I think the real critical piece is to do what some of the utilities are doing. I mean, if you look at SoCal Ed's map for what they're planning to do with software and integration of systems, and recognizing at the end of the day, yes, the electrons move, but this is about bits and bytes. It's an information game, right? The electrons will flow where the electrons will flow. It's all about planning, and it's the what, the where, the when, and how much. So I think the critical piece is really having those informed conversations around what is feasible and what are the underlying information systems that are going to be necessary to enable this transactive grid. And then I think, what James is doing at SMUD and some of these utilities that are pushing the envelope, making sure that we disseminate those lessons, both the failures, which there will be, and the successes really rapidly, so that we can fail fast and move forward as quickly as we can, knowing we're going to incur some casualties on the field in terms of wasted money and so on, but absolutely necessary because we're facing the imperative of 1.5 degrees or worse within the next 30 years. So it's not like we have a choice. There's no luxury for us to be able to sit around and overthink this thing. At some level, we do have to move forward and we will make some mistakes, but it will come down to really thinking about architecting this information and building these open access platforms in ways that make the most sense to people.
Yeah, well, let me just push you on that. Are you as frightened by that DOE map in terms of all those new wind and solar farms and all the transmission lines interconnecting them as I am? Because I mean, I don't know what ratepayer would be willing to pay for all of that stuff.
Well, you know, I worry about, first of all, will it get built and will the NIMBY thing? But if you think about it another way, for the last X number of decades since we started this game, we've been consuming electricity without paying the full price and asking our kids and our kids' kids to pay the rest of the bill, right? Which is future hurricanes, floods, winter storms, and all that stuff. So in essence, in my whole lifetime, I have underpaid for my electricity bill. So I think when we say, oh, we don't want to pay anymore, we're fooling ourselves. And to some degree, that may be a level of BS where we haven't really reckoned with the fact that what we've done up until now, we didn't know for a while that we were acting in some sense immorally, stealing from future generations. But now those of us who are informed know that. And so we may have to end up paying a little bit more if we really want to avoid the damage that's going to happen after we're dead and buried. That's a moral question as much as anything else, Gary. I hate to say it. It ain't just dollars and cents. It's, do we love people we will never meet? Our children and our descendants.
Right. Well, and in some sense, the magic of having the regulated utilities says you can afford to pay this off over 75 years because you've essentially given them a guaranteed mechanism to collect the money. So I don't know, haven't done the math on how big a jump that is, but let me turn to James on what SMUD is doing. I'll give you another one of my fears. I see all of this talk about let's get faster and faster chargers for EVs, which, you know, Kirchhoff's laws and simple math says if you're going to build like an 8 to 12 bay fast charger that can give you 300 miles of range in 10 minutes, you know, back that up. And it's sort of like, if you're not collecting or connecting at a 69 or 115 kV substation, you're melting the distribution network trying to push that much power. And I've had what might be a bad thought here, but it's sort of like, if a lot of things and PR won't do it all, you could have like a surcharge on EVs because you're going to have to put a lot of investment in there, and maybe that pays for some of the physical infrastructure. So I get the point of trying to avoid a lot of new concrete and steel, but I also worry that there's going to be a necessary upgrade to the distribution network to provide the infrastructure for a lot of these fast chargers. Have you encountered that in your
Yeah, so you're actually starting on one of my favorite topics there with electric vehicles, because it really lends itself to the first question you asked of kind of how far can we push these DERs, and then the follow-on question of what is the impact of the DERs going to be, and kind of in that context if left unchecked. And I like to start that conversation with electric vehicles because electric vehicles are happening. It doesn't have to necessarily be a utility-enabled or engaged future. The shift towards electric transportation is underway, and California is fully behind it. And so when we look at EVs from a utility perspective, we largely have the conversation in terms of electric vehicles are either going to happen with us and help be part of our solution, or they're going to happen to us. And these business models are going to evolve to serve those customers and those charging needs. When we look at Sacramento alone, there's just above 100 or just above 1 million vehicles in our service territory today. So you can imagine by 2045, when we get to a point where a majority of those are electrified, the charging needs of those electric vehicles. And it's not just those kind of corridor supercharging stations that you're talking about, but it's how do we go from building 50 kilowatt and 100 kilowatt DC fast chargers today, reaching the 6-minute charge goal that is the gas station equivalent, but also building out infrastructure for workplace charging, building up infrastructure to support residential charging at 7 to 19 kilowatts, when the most that a typical house consumes today is closer to 5 kilowatts. So it is not just disruption at those larger points, but it's disruption really at every single endpoint of the grid when we think about electric vehicles. And so the answer to your question is yes, there will need to be investment. There will need to be additional build to allow that load to come online. But there needs to be engagement with those devices, engagement with those technologies to also help support the larger grid operation. And so it's not enough to just say, great, we can serve all the charging load in Sacramento, we did our job. That's not sufficient. We need to go that extra step and to say, and we've partnered with EV charging companies, and we've partnered with electric vehicle drivers, and we've implemented managed charging programs and workplace charging programs that align EV load with solar generation. And we're dynamically managing V1G and V2G programs so that we limit that individual peak impact. We maximize the energy that could go into all of those electric vehicles. And we're doing it by using those vehicles as a resource rather than letting them happen to us and standing idle until the problem is too big for us to actually engage with. And so we're starting today rather than waiting for tomorrow.
Well, I think that's a great thought. And, you know, in some respects, you have more EV charging, you have more control points, more controllable load. And I know there's reluctance, and for very good reason, for the utilities to just want to see the grid backfed from resources that are deep within the distribution system. But, you know, I can also imagine a solution that, you know, you have so much EV charging, and if it's controllable, and if you have excess generation from a behind the meter resource that could be backfeeding, you could match those up and not have to do a lot of rebuilding. Is that something that you're thinking about too, James?
Yeah, and so it was around 2017 where SMUD kicked off our investment into a major ADMS distribution management system and DERMS distributed energy resource management system upgrade. I think something on the order of $20 million to revolutionize our distribution monitoring and metering system so that we have data visibility into those endpoints all the way down on the distribution system, so that we can actually engage with these endpoint devices with the level of data and insight that Tim was referring to in his presentation earlier, so that it's not just we know that a failure occurred, but we know those specific loading points, and we can think about how to thoughtfully dispatch those resources, either to increase load, to drive that consumption of those cheap resources, but also to decrease load to manage infrastructure, be it on a locational level or on a system level.
Yeah, no, I agree with that. And SMUD made an investment, some with federal money, in putting in smart meters throughout the system. And I made a comment to somebody, fortunately I didn't publish it. They said, you know, what do you think about that? And I said, well, it's a baby step. You know, it's not smart enough. You're going to have to put a whole another layer upon layer upon layer of intelligence into the system to make this work. And we need to be thinking about how we do that intelligently and pay for it. So let me turn to Tim, because you made a lot of points on doing it intelligently and paying for it. And so where are we in the amount of intelligence control monitoring that's going to be needed to achieve the maximum effect of DERs in the system? Still at baby steps?
I think we're making progress. There are market drivers now for companies to provide that intelligence to utilities. I think that aligns a lot with some of the issues that we're seeing with wildfires and failures and the damage that they can cause. Kind of going back to your first question to Peter, I think the grid is in debt in terms of maintenance as well. And climate change and these extreme events, weather events, are not doing anybody any favors. And so to me, I think we're reaching a point where equipment is going out of life. We have a decreasing workforce, and we don't really have a choice. There will need to be upgrades. And when we talk about these big federal level infrastructure packages, I think the biggest opportunity to reduce cost is by directing it in the right places, because it's almost certain that this money is going to be deployed to the wrong place to a significant degree. And people don't have the necessary information to make these decisions. And kind of what Peter said, we've got to do something. We can't just sit around here waiting for this information to present itself. These wildfire events, and we have now fire years, not fire seasons anymore. And you just have to open up your Google News and there's something related to the grid on a daily basis. But people really are starting to see the impacts of this core problem that just people that we haven't been tackling, which is an aging infrastructure that is going out of life and a diminishing workforce with increased frequency of extreme weather events. What can we do about it? I believe that we need to bring the necessary information out onto the table for all the relevant stakeholders and decision makers to prudently deploy that capital. Because when you think about a distribution circuit as an example, you don't have to replace that whole circuit. There are only single points of failure. And if you knew exactly where to deploy that capital, then you would have the remainder of that money to deploy. And so you can abstract that and take that to the whole utility level, to the state level, and to the federal level. If you understand the causality, you understand not just where and when things are going wrong, but you understand at the macro level why. That is really what's going to inform the prudent decision making that will drive down the cost of what needs to happen. We need to do upgrades. It needs to happen. Now the discussion needs to be about how do we get this information as quickly as possible and do something about it.
If I can add one thing.
I agree with that.
The American Society of Civil Engineers put out their infrastructure report card, and the amount of underinvestment they expect by the year 2029 is $208 billion. The amount that's in the infrastructure bill for the grid is 76, and the estimated damage borne by the commercial industrial sector by 2029 is expected to be $935 billion. Now, granted, it's in the civil engineers, they speak nicely to each other because they're civil, but it is in their interest to pump those numbers up because that's what they do for a living. But nonetheless, it's non-zero. There's a real problem there, to Tim's point.
Well, I think you're absolutely right. And I mean, react to Tim's point that it's almost certain we're going to deploy money to the wrong places, which is what you see government do all the time. Do you see that happening too, Peter?
Yeah, I do. There's a certain amount that's inevitable because they're not close to the ground the way some practitioners are. And there's also issues like political pressures, unions, certain states, that sort of thing. There's going to be, without question, a certain amount of waste. That's always been the case, whether it was fighting World War II or whatever. The question is whether or not we let the perfect be the enemy of the necessary here, not just the good, but the critically important.
Well, I'm sure there's some concrete and steel that we're going to have to install, and aluminum. But I just see so many monuments on the ground of unfinished projects that history passed by.
But it
worries me. This is the big one.
Can I add one? So there is one really interesting model out there. So, and some of you are probably familiar with BQDM, which isn't a rock group. It's Brooklyn Queens Demand Management Project. And this is a situation in Brooklyn and Queens where yuppies moved into certain areas and essentially drove an evening peak from 7 to 10:30 or 11 at night. And Con Ed was looking at up to $1.2 billion for a substation and feeder. And instead, they said, what if we put in fuel cells, demand response, solar, batteries, and some permanent energy efficiency? What would that cost? And they did all that. They got 51 megawatts of demand response targeted to those hours of the day, plus some investment in voltage reduction for a little over $110 million. So less than 10% of what they would have had to spend. So in this DER conversation, and James is abundantly familiar with this concept. I know it's in the planning documents that SMUD has, and I know Tim's been focused on this, we can use DERs very effectively to target some of these investments we would otherwise have to make by either forestalling them for 10 years or eliminating them entirely by putting batteries and other DERs in the right places strategically and tactically.
You'll
Let's
notice
talk
in a
dollars and
lot of-
cents.
I was
Go ahead,
going to
Jim.
say you'll just notice in a lot of the conversations that I was having in kind of the presentation material that I had, that a huge amount of the intent, that the efforts that we're looking at with DERs right now are not to universally reinvent the system to enable DERs, but rather to bring DERs into those commonplace conversations, so that when we're thinking about, do we build a substation, it's not whether R&D happens to be in the room or not to say, hey, what about batteries? What about behind the meter? It's actually a tool in the grid planner's tool belt and the distribution planner's tool belt that they always make that consideration. The DERs are always on the table, and that they can make the decision that says, this is the most cost-effective approach in this situation. And it's not using DERs for the sake of DERs. It's not building for the sake of building. It's making the right choice and having the best available set of options. And that's really where we see the value of this conversation, and just establishing the technology as an available tool and standardizing it.
Well, and let's expand on the dollars and cents question here. As I observe things, net metering is diminishing in a way to encourage the installation of a lot of DERs, solar and wind, et cetera, which is not irrational, because we said, if you have a grid, you need to make more investments in it to upgrade it. The cost is independent of utilization. You're probably not going to pay for it on a kilowatt hour level. On the other hand, you can pay for it through credits, pay for the installation of solar and wind behind the meter, et cetera, credits for resource adequacy, resilience, fast ramp rate, all of that. In California, I think we're kind of lagging behind in what we're willing to pay for those assets right now. I think PJM has been more generous in how they figured all of this out. I know CalISO would like to be more aggressive on this. What's your sense, James, as to where we are in being able to pay more to incentivize people not only to put in solar and batteries, to put in the monitoring and control equipment that Tim says we need in order to get maximum benefit?
Absolutely. And so for us, it really did start with that investment in the ADMS to provide that grid level visibility so that our operators know what's going on. That being said, this is actually an advantage that SMUD has, because we are vertically integrated, because we do manage the Balancing Authority of Northern California, because we are our system operators all the way down through distribution and point of delivery. The virtual power plant program that we are working on and will be actually putting out a solicitation here pretty quick, is a program that pairs an upfront incentive for battery energy storage. So for residential, up to $2,500 per system or per household, $250 per kilowatt hour, with a ongoing participation payment. So a customer is going to be getting $1 per kilowatt year payment for participating in the program. And that's not necessarily a payment that is predicated on, here's exactly how we're going to operate it. That battery system is going to be contributing to our capacity planning, to our resource planning, to our grid operations. And we're looking to establish a partnership relationship with a set of customers and aggregators that actually mirrors the type of relationship that we would have with a traditional power plant or a conventional power plant. So bringing those capacity benefits, those capacity payments into this virtual power plant conversation, and really trying to do what you're talking about in a leading by example type of way.
Well, take that a step further, because one thing you mentioned was trust in the DERs. And we've had a few summers out here, and CalISO called on some of the resources, mostly load management resources, didn't get the response that they really needed. And, that's caused some continuing problems. Where are we in
You know,
people's feelings about whether you can trust the DERs to have the impact on the system that you'd like.
it was kind of a bummer when a lot of those capacity calls happened that, an individual's house might have been using 2 kilowatts and maybe they have a 10 kilowatt battery installed. And given the rules of the game today, those batteries supported 2 kilowatts. There was 8 kilowatts on the table from that household times however many households across the state could have continued to help. But they weren't allowed to export that energy from the battery to help be part of the solution. And that's not quite good enough. And so as we're looking at virtual power plant, as we're looking at rolling out our critical peak pricing rate next year, one of the things that we're doing is making space for batteries to actually export to the grid so that they can participate in these services to their full capability and not be limited by what that customer load happens to be. If you're
Right.
a participant in my virtual power plant program and you're on vacation and I need the capacity from your battery, I don't care that you're as an individual on vacation. I need the capacity because the community needs the capacity. And I want your
Right.
system to be able to show up and help. And that's one step towards building that trust. And the second step is then when we ask for something like 10 megawatts, that the portfolio delivers 10 megawatts to plan. And that's the demonstration path and trust that we're building.
So when you go to the silo next door at SMUD, to the T&D planners and engineers, and you talk to them about backfeeding the grid from, 1,000 battery systems, what kind of resistance do you get there from the idea of that backfeeding?
It comes down to that visibility question. In a world where they don't know what's going on at that distribution level, it causes angst. It causes uncertainty. And uncertainty for any utility, one like SMUD that's been operating for over 70 years with high reliability and performance criteria, uncertainty is scary. And so I think that there is a trust building exercise that has to happen there. Data and visibility, that grid edge information is a huge part of building that. But at the same time, it should be a fairly significant barrier to build that trust, because customers have a very high expectation for reliability. And if we lose that trust from customers that we will be reliable, then they will no longer want to participate in these types of programs. And so we have to move quickly, but we have to maintain our high level of expectation in terms of service and reliability. Otherwise, customers are just going to walk away from the greater good.
All right. So let me say, in the nature of load management, Thomas, I'm at my sister's house in Indiana, and my load management problem is now it's blinking that says I'm about to run out of battery. So I'm going to run and get the cord because I don't even know where the plug is in this office. But let's hear from Peter to respond to some of the things that have been said. And then Thomas, why don't you take some questions from the audience while I run and go get the power cord. Okay?
Yeah. Well, one other thing that's really interesting is if you look at, there's a couple critical pieces here. One is you look at a number of different studies that show the top 1% of demand, the infrastructure required to serve that is roughly 8% of overall capital investment. So anything we can do to take DERs and flatten that thing out, move it to the side, shift the load, reduce the peak, we can get money just from not having to build or maintain infrastructure, which is really relatively unnecessary if we manage the grid better. That's gravy. So that's a critical piece of it. The other thing is, yes, batteries are a critical piece of the equation, but if we just made all the water heaters in this country responsive, there's massive thermal storage in every water heater. There's gigawatt hours of storage. Problem right now is it's a retrofit situation. We need all the water heater manufacturers to all have the same UBS, the same way we do on our computers, so they're all attachable in the same fashion. There's work being done on that. It's kind of like the Golden Carrot program and the super efficient refrigerator program in the 1990s. Like, we know how to do this stuff. We just have to bring more intelligence to that game and do it pretty quickly. The other great thing is water heaters are designed to be useless after about 11 years. They need to be replaced. So we could cycle through the population of water heaters pretty quickly and make them all load addressable, which would be a huge opportunity for somebody like James and SMUD and Tim with his software, et cetera. So there's a lot of things out there right now that we can do that have relatively minimal impact. The report the BPA did on water heaters indicated, yeah, they screwed up and a couple people had cold showers, but not that many. That's not a difficult problem to solve. And so I think we have to move with more alacrity on some of these assets that are staring us right in the face right now.
I want to take a moment to
I'd encourage everybody to look at our PowerMinder heat pump water heater, controllable heat pump water heater program, which is part of our energy storage virtual power plant conversation.
I would highlight that
There we
SMUD
go.
does have rebates on several things that are going to be part of the solution here, from smart thermostats to controllable water heat pumps. I want to call on Peter Mackin because I know you've had your hand up. You want to ask your question or?
Well, it's actually more comments than questions, but you know, I've listened to everybody's chatting here, and it's really thought provoking. But one thing I would say is that you know, I think the fear that costs are going to go up when we have to add transmission might be misplaced, because you know, the cost of solar, the cost of wind, the cost of batteries are all going down, 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 down. So the LCOE from these renewable resources is less than what it costs to generate power with thermal resources these days. So you can afford with those savings to build some transmission if you need to. That's not to say that you don't want to, you know, put some resources on the distribution grid. I mean, I agree that's a great way to, you know, even maximize your resources and utilize your wires better. But you know, I mean, to think that just because we've got to build gigawatts of renewables to get to zero carbon means that we're going to have to, you know, spend, you know, billions of dollars on transmission, and it's going to cause the rates to go through the roof. That may not be the case. The other thing I would wanted to chat about a little bit, since I'm a SAC EV guy, electric vehicle guy, is that, you know, this thing with the fast charging. You know, a 350 kilowatt charger, if you had as was mentioned earlier, if you have a bay, let's say a plaza with 24 bays, that's only 8.4 megawatts. I mean, sorry, I said only. But one single express feeder from 12 kV can handle that, no problem. So you know, and the other thing I would point out is that you don't need a lot of these 350 kilowatt chargers, because most people are not going to use them to charge their vehicles. They're going to use them only when they're on road trips and they have to go, or they're going a long distance and they need to go and charge up quickly. Otherwise, they're going to be charging at home, or they could be charging at work. And that's, I mean, that's the big thing that I'm harping on, and all of our SAC EV members, at least on the board, are harping on, is workplace charging. And James mentioned that too, because, you know, and it even helped Peter with his, what tummy tuck the duck thing, because if you can get workplace charging in place,
Right.
charge those vehicles while they're sitting in the parking lot at work,
Yeah.
you basically absorbing all that extra solar that you would either curtail or pay people to take from into another state. So,
You know, and one point on that. Oh, actually, ABB just came out with this week a 360 instead of a 350. But it was also made, and it was just this week. It's also really clear, and the battery manufacturers will tell you, with today's chemistries, you deteriorate the life of the battery if you fast charge it too many times. It's not good to fast charge, and it's not good to charge it up to 100%. Now, there's new chemistries coming online. Contemporary Amperex is looking at sodium. Things are evolving. So your point is well taken on that. The other piece is your point about renewables. Nextera had a presentation, investors presentation, about 9 months ago, where they said the cost of new natural gas fired combined cycle plants, LCOE, was roughly $40 a megawatt hour. It was actually more expensive than that to operate a coal plant. They said that wind right now, with 4 hours of batteries, falls in the best wind regimes in the $20 to $30 a megawatt hour range for those LCOEs, and solar in the 30 to 40. And we're still seeing, even though we have short-term supply issues right now, the curves are still going to come down. So your point is well taken. For the hours when those assets generate, those are the cheapest electrons being dumped into the grid right now.
I want to,
And what-
on electric vehicles, I also want to highlight, I think I've seen 4 presentations by Ford, BMW, Audi and one other, where all of them were talking about their development is on the assumption that their batteries are going to back up the grid in some aspect. Now I know SMUD is really cost sensitive, and especially when they've had now the belt of the cheapest power in the state for some time now. And if you've been to a SMUD board meeting, there's always someone complaining that it's too expensive. So I'm wondering, one of the goals set out by Peter Lau was that you're not going to raise costs on any of this. What are some of the trade-offs you're considering when you want to put these VPPs and BERs out there? What are you kind of considering to keep those costs in line?
So that's a big part of what I talk about when I say that we're not trying to create a solution that guarantees that behind the meter batteries are the answer, or that electric vehicles are the answer. We believe that DERs and virtual power plants are a massive opportunity, and in some way, shape, or form will be a very meaningful component of the long-term solution and reaching zero carbon in 2030. But we are not today making a blanket statement that says, this is exactly how we're going to do it. This is exactly how many batteries. The objective is to get these resources to a point where they are understood, the upsides and downsides are quantifiable, both in terms of reliability and cost, and that we can make that decision side by side with other resources, so that when we are accelerating DERs, when we are accelerating batteries, when we are accelerating electric vehicles, and I'm not talking about in the next 3 years where we're ramping up, we're obviously going to be investing in nascent areas and technology spaces that inherently is more expensive than market alternatives. But long-term is really where I'm talking about, is having these solutions side by side and being in a spot where we can make that most cost-effective solution. Because at the end of the day, it might end up being that electric vehicles are the premium solution for energy storage in the grid, or that water heaters are the premium solution. It might also be that declining costs of battery energy storage really dominate the marketplace. But we're not picking winners and losers. We are investing in the framework and the foundation to enable the technologies that provide the best cost and best value to thrive and proliferate, without over investing in the technologies that don't end up delivering on the hype that we see today, whatever that technology may be.
All right, Gary, you want to take it away? You're muted. You're muted, Gary. You look very passionate.
There we go. You'll appreciate the irony of I'm living while I'm on vacation here in my sister's house. It's a gold medallion home. It's all electric. It's, the dream of everybody to do decarbonization, but it was built in the 1970s. And so few of the plugs here have a grounded outlet. So my problem in keeping the battery charged on my computer was simply trying to find an outlet around here that would take the grounded plug from the charger. Mistakes in infrastructure development. So let's just give an opportunity for a final comment from each of our speakers, whom we very much appreciate. It's been a great discussion. And maybe, of course, for a lot of people we have in our group, questions for the business opportunities. Sounds like software. Sounds like there's some control devices that would be helpful. Peter Mackin talks about his water heater lasting 25 years. You're lucky. Where some of the opportunities will be, and where's the money going to be made in this? So, Tim, you want to give a final comment and anything you want to add there, or comment on where the business opportunities are? Question.
Yeah, I think what needs to happen is the utilities need to get ahead of this because there's huge market drivers to the adoption of DERs, to electrification of vehicles, and not just SMUD, but utilities in general should react now, not retrospectively. And I think that there is a vision or a way that this happens well, but it involves setting up the market drivers for people to participate. And I bring up this example because if you look at Australia right now, just within the last couple months, people that participate in solar now have to pay to export electricity because supply, there's oversupply. And this is just an example of the necessary structures not being deployed effectively. And so again, it all comes back to more data for planning, more data for situational awareness. The utilities can't get enough of that to be able to make and deploy these strategies efficiently and effectively.
I think Energy Australia and the other markets over there, they're ahead of California in terms of what they do in incentivizing integration of DERs and having systems that communicate. So I hope we catch it. Peter, what's your view on this?
Yeah, I like what James said. One thing about that Australia situation, Q1 from 10 o'clock in the morning to 3 o'clock in the afternoon in South Australia, the average spot market price was negative $12 Australian across the entire Q1. That's how bad it got. I think James is right that we really have to think, this is a heavy lift, there's no question. And not picking winners and trying to create optionality through the creation of the platforms and the programs that allow the right technologies to migrate to the right places as much as possible, I think is a smart way to go. Yeah, we have to get off the time, we have to get moving, we have to take advantage of those inherent elasticities within our customers and our devices that will respond to prices. I think it is dangerous to pick winners and losers. Sometimes we have to do that to spur certain technological development, otherwise it won't happen. And so subsidies, you wouldn't have had a solar industry, for example, if Germany did not do the feed-in tariffs, simply wouldn't be where it is today. But I think SMUD's approach on a lot of this is right. Move fast, try and be nimble, try and be responsive to what the market wants, and know that you're going to have to keep on evolving with the facts on the ground as they continue to emerge.
James, no comment?
Yeah, so the thing that I'd like to kind of leave everybody with is that when you're coming at these conversations from a business side and you're thinking about your business strategy, or when we're coming at this from the utility side, we maybe are thinking about our resource planning strategy or our DER strategy or our customer strategy or our under-resourced community strategy. There's a huge number of different conversations that happen both within utilities, at balancing authorities, in the private sector, all of it kind of with the flag of strategy surrounding it. And the thing that I'd like to raise as being the biggest opportunity to actually have large impact in this space is that it's not good enough for strategies to be individualized anymore. That this really is a solution set that requires broad collaboration, both inside utilities and outside utilities, both within the private sector and the public sector. And so as everyone is developing strategies, as everyone is looking at business models, as everyone is looking forward, utility or otherwise, thinking about these strategies more holistically and asking the question of how do they overlap, how do they intertie, what are the points of convergence, and how do we build lasting solutions that are good enough to be win-win for everyone long-term. Individuals may not rise all the way with respect to different companies, but overall to create sustainable industries in the industry arena that benefits individual customers, communities, and that utilities can continue to provide low-cost electricity. So working together is the message that I really see as being the biggest opportunity for conversations like this.
All right. Thank you very much.
That and yeah, thanks very much. We're at the close of our time, but this is a topic that goes on. We've already had 2 other sessions great on it, so we're sure to invite you back and let's continue the conversation, because this problem is going to be around for a while. And a lot of the conventional ways of looking at it are going to be changing. And so with evolution comes opportunity, and that's what we're looking for. Peter, you and I have traveled all over. I got to tell you, one thing that always amuses me is in the world, we can't seem to agree on what an electrical plug looks like. So I'm hopeful we can do a better job on it, that sort of thing in the future. So round of applause for everybody that spoke today. Thanks for everybody who was putting in questions. We've tried.
Oh, it looks like we might have lost Gary there, but yes, thank you, everyone. Sorry we didn't get to, we got some good questions late there. I really wish we could have answered them, but I want to thank our presenters for coming and talking with us. James Frasher, Timothy Barat, and Peter Kelly-Detwiler, especially Peter Kelly-Detwiler for proving that you don't have to have a beard to be in energy.